apparatus according to IGCSE syllabus. It is the topic 2.1. What are the objectives to be achieved regarding laboratory apparatus? You have to be able to name the pieces of apparatus used for measuring volumes of liquids, volumes of gases, mass, time, and to be able to record the measurements of volume, mass, and time on a given piece of apparatus. First of all, apparatus for measuring volumes of liquids. We have three types of pieces of apparatus used for measuring volumes of liquids: burette, pipette, and measuring cylinder. We have two types of pipette. One is volumetric pipette, the other one is measuring pipette. How they differ, we are going to explain throughout this video. Measuring cylinder. If you look at measuring cylinder, it has a wide neck. Because of that, the measuring cylinder measures inaccurate volumes of liquids, while the burette and the pipette, both of them have thin necks. Because of that, because of having thin necks, they measure accurate volumes of liquids, while the pipette is more accurate than the burette because of its thinner neck. So the pipette has thinner neck. Because of that, it measures more accurate volume. The neck of the pipette is thinner than the neck of the burette as it appears here. Apparatus for measuring volumes of liquids, we are going to explain more details about the burette, its use, and how we measure the volume of the burette. The burette is a long graduated glass tube with a tap at its bottom. As it appears here at its bottom, there is a tap to control the addition of the volumes of the liquid. The good advantage of the burette is it measures accurately the volume of one liquid delivered to another liquid. If we look at it, it is graduated at the top with 0, and as we go down, we reach 50. So when it is evacuated, once the liquid is delivered, it starts losing volume from the top. So we measure the volume from top to bottom. The burette is available in two measures, 50 centimeter cube and 25 centimeter cube, but the 50 centimeter cube is more commonly used one. Where do we use the burette? Usually we use it in titration to measure the exact volume of an acid needed to neutralize a known volume of an alkaline solution placed in a conical flask, as well as in a redox titration, because we have acid-base titration and redox titration. The burette can measure volumes with decimals like 5 centimeter cube, 5.1, 5.2, 10, 10.5, and so on. This is how the burette works. The volume starts decreasing as we open the tap at the bottom, and the liquid starts dripping. Then when the color changes, this happens during titration, we stop the burette and we read the volume. Because we have curved here meniscus at the top of the liquid, so we need to know how to read the volume of the liquid. We put our eye horizontal to the bottom of the meniscus, like this. Some people might look from top or from bottom. their readings will not be correct. The correct position for reading the volume of the liquid is by putting your eye horizontal with the bottom of the meniscus like this. In this case, the volume will be 17 centimeter cube. In other cases, we will get wrong readings as it appears here. The correct one is 17 centimeter cube when we put our eye horizontal with the bottom of the meniscus. Regarding the pipette, as we mentioned before, there are two types of pipette, volumetric and measuring pipette. The volumetric pipette, also we have a teeth pipette. The volumetric pipette measures accurate fixed whole number volume. The volume is whole number and it is fixed. Why? Because it is available in two measures only, 10 centimeter cube and 25 centimeter cube. If it is labeled with 25 centimeter cube as it appears here on the diagram, then it will measure 25 centimeter cube only. So because of that, because it measures the volume that is labeled on it, so it is used for measuring fixed volumes like what? Like 10 centimeter cube and 20 centimeter cube only. We cannot measure with the volumetric pipette, for example, 24.5 because it doesn't have graduation. Measuring pipette is better than volumetric pipette because it has the advantage of measuring accurate volume of liquid with decimals as it has graduation. We can use it to measure, for example, 3 centimeter cube, 3.5. And if you look, it is read the same way we read the burette because it measures from top to bottom, as it is labeled with 0 at its top and 5 at its bottom, and it delivers the liquid from its bottom, not like the measuring cylinder. So it works the same way like the burette, but unlike the burette, it doesn't have a tap at its bottom. The teeth pipette is another type of pipette. It measures small volumes with lower accuracy than the two types of pipette, volumetric and measuring pipette. The measuring pipette is available in many measures, 5, 10, 25, and so on, used to transfer accurate volume of liquid to a conical flask. All types of pipette are used for this purpose. Comparing between teeth pipette and the dropper. The dropper adds drop by drop and we don't measure its volume, while the teeth pipette transfers up to 5 centimeter cube liquid. It works same as the dropper but delivers measured volume. With the teeth pipette we can measure the volume we add, 1 or 2 or 3 centimeter cube, while with the dropper, no, we just add a few drops without measuring the volumes of these drops. Measuring cylinder, the third type of apparatus used for measuring volumes of liquids. The measuring cylinder measures inaccurate volumes of liquids because of having wide neck, not thin neck. It is used because of that when accuracy is not needed, such as when we need to measure the volume of the reactant which is in excess in any reaction. Because if the reactant is in excess, then no need for accuracy. If we compare between measuring cylinder and pipette, measuring cylinder, its advantage is quick. No need to fill and deliver slowly. But it has a disadvantage which is inaccurate, as we mentioned before. The pipette, its advantage is accurate, but a disadvantage of the pipette is it is slow. Apparatus for measuring volume of gas is gas syringe, used for collecting and measuring volumes of gases. Time. We use stopwatch to measure time in the lab, and it is accurate. Temperature. We use the thermometer. To measure accurate masses, we use top band balance. But if we need rough mass of solid, we use spatula. In general, they say transfer to spatula measure, like when they say put 2 spoon measure of sugar on tea. So the spoon measure is not very accurate, but it has very approximately known mass. If we take 2 different spoons or 2 different spatula of same substance, their masses will be very close, but not accurate. Flasks and beakers. There are many types of flasks. Starting with the beaker, it is like the rectangle, okay, and trough. Trough also like the rectangle, but not long as the beaker. Gas jar, used for collecting gases. It is thinner than the beaker. Conical flask, it has this shape, and we will mention its use later. Round bottomed flask and flat bottomed flask, as well as volumetric flask. This is the most important one. Why? Because the volumetric flask is the type of flask we use to prepare solutions of accurately known concentration. Whenever we need to prepare a solution, the solution is prepared inside volumetric flask because it measures accurate volume. So we cannot use round bottomed or conical flask or any type of flask because these do not measure accurate volume. But the volumetric flask measures accurate volumes. Because of that, we use it for preparing solutions of accurately known concentration. We fill it to the etched mark on its neck. When we fill to the etched mark, it means that the volume inside the volumetric flask equals to the label on it. Like the one on this diagram, it is labeled with 250 centimeter cube. So till the etched mark, the volume will be 250 centimeter cube. Its available measures starting from 50 centimeter cube, 100, 250, 500 centimeter cube, and 1000 centimeter cube. Funnels. Also, we have many types of funnels, starting with filter funnel, tap funnel, pistil funnel, and separating funnel. Filter funnel separates small insoluble solid from a liquid, such as calcium carbonate from water. This is used in filtration. Tap funnel. It's tap because it has a tap. It allows us to control addition of the liquid slowly, and we can add the liquid in portions. Small portions, not all the liquid at once. Pistil funnel for filling tubes of thin necks with a liquid. If the tube we need to fill, like the burette, if we need to fill the burette with a volume of liquid, we need to use pistil funnel to put it on the top of the burette. Then we fill the burette by passing the liquid through the distal funnel. Separating funnel is a very important type of funnels because it separates immiscible liquids such as oil and water. Immiscible liquids are liquids that do not mix with each other. As we mentioned, like oil and water do not mix with each other. The lower layer is the less dense liquid. The upper layer is the more dense. If we try to mix water with oil, the mixture will be heterogeneous and they do not mix. We will see two layers. In the upper layer, we will see oil. So oil is less dense than water, and in the lower layer, there will be water, the denser liquid. Other lab apparatus, tripod. We can see it drawn like the first diagram or the second diagram. Gauze. The gauze is this shape, okay, like sieved metal. It is the piece that we put on the tripod to distribute heat. Also, we have Bunsen burner and watch glass as well as bottle, wash bottle. Evaporating dish, delivery tube, spirit burner, condenser, mortar and pestle for grinding and crushing solids of large pieces. We have the bunk, the test tubes rack, boiling tube, stand, and standy clamp, as well as metallic tongue. Metallic tongue is used to handle hot beakers or hot pieces of metal in the lab. Uses of laboratory apparatus mentioned before. Gas jar. It is used for collecting gases we mentioned before, either by upward delivery or downward delivery. The gas, which is denser than air, is collected by downward delivery. The gas, which is less dense than air, can be collected inside the gas jar by upward delivery. But the gas jar is not the same like gas syringe. It just collects small samples of gases and doesn't have the property of measuring their volumes, while the gas syringe collects and measures volumes of gases. The condenser condenses vapor into liquid. It is used in distillation apparatus. Mortar and pestle for crushing and grinding solids. Bunsen burner, heater which burns crude oil gases such as butane gas. Gauze, distribute heat as mentioned above. Metallic tongue for holding hot objects, also mentioned. Spirit burner, heater which burns liquid fuel such as ethanol, unlike Bunsen burner which burn gases. Crude oil, crucible for heating solids to very high temperature. If we need to heat any solid, we will need to heat to very high temperature. We don't put in a test tube because the test tube cannot withstand the high temperature, but the crucible, which is made from porcelain, can withstand very high temperature, so we heat solids to a very high temperature inside a crucible. Clamp holds the apparatus to the stand. Test tubes rack holds test tubes. Boiling tube, a type of test tube used for reactions where heating is required. So in every reaction where heating will be required, we don't use a normal test tube. It will break quickly, but we use another type that is manufactured to withstand high temperature, which is called boiling tube. Wash bottle for rinsing glass tubes, funnels, burettes with and etc. with distilled water.